Unit 5, Lesson 4. We're going to take a little review here of compound interest. So far we have two formulas that we've been given and we've been using. A equals P bracket 1 plus I to the end. That's to the end. That is for a future amount. And P equals A bracket 1 plus I to the negative n. This is for a present amount, or an amount that I need now to get something in the future. So your job now is going to be able to know, or going to be able to read a question and know which formula you need to use. So you've got to read carefully whether you're talking about an amount in the future or an amount you need now. So question number 1, determine the amount of $5,000 invested at 5% compounded semi-annually for 10 years. So determine the amount of that invested at 5% semi-annually for 10 years. So that means we're looking at an amount in the future. So we're going to use A bracket P 1 plus I to the n. So our principal is $5,000, 1 plus 0.05. Compounded semi-annually means that we have to take our interest rate and divide it by 2, and our time and multiply it by 2. So we're going to have an exponent of 20. So previously we've always made our list at the side. If you want to continue to do that, feel free to do that. Or you can do your calculation in your head to adjust your n and your I and put it into your formula. Whatever works, as long as you remember to adjust it. So I've got divided by 2 is that, and I'm going to add 1 to it, an exponent of 20. And then I'm going to multiply by 5,000. And that gives me $8,193.08 as the future value of that money. Okay, example number 2. Determine the principal needed to grow to $2,500 in 4 years if interest is 8.2 compounded quarterly. So the formula we need is basically stated right in this question. Determine the principal. So we're solving for P. That means we need our present value formula. So our accumulated amount is $2,500. 4 years compounded quarterly means I'm going to have 1 plus my interest rate divided by 4 for quarterly, and 4 years times 4 times each year is negative 16 as the exponent. And then I should be able to calculate that. Get my calculator going. So 0.82 divided by 4 plus 1 to the exponent negative 16 times 2,500. And if you remember, when we do present value, our answer should be smaller than what we started with. So we need $1,806.89 right now to get $2,500 in the future. So next one, what annual interest rate is needed for $5,000 to grow to $7,000 in 5 years if interest is compounded semi-annually? Okay, so we're figuring out the interest rate this time. We know our A and we know our P. So which is which? We're going to have $5,000 grow to $7,000. So the A is the accumulated amount, so it's always the larger. And interest is compounded semi-annually for 5 years. So we have got $7,000 and our principal and 1 plus I. And 5 years, twice a year would give me an exponent of 10. So we're going to rearrange our equation and solve for I, which means I'm going to have 7,000 divided by 5,000. And when I do that, sometimes that divides nicely and I get a nice number, and sometimes it doesn't. So this time, when I try to divide it, I get 1.4. 1 plus I to the 10. And if you recall, to get rid of our exponent of 10, we're going to do the 10th root of 1.4 and then subtract 1. and we'll get our I. Once I get my calculator working, there we go. 10th root, 1.4. I could type better, 1.4 10th root minus 1 is 0.034, so about 3.4%. And last one, oh, I lied, there's two more. How much should be invested now so that you can have $9,150 in 9 years if interest is 3.8% compounded monthly? So that's the amount I'm going to have in the future. So if I want to know how much is invested now, I need to use my present value formula. 9,150, 1 plus 0.038 compounded monthly, so divide by 12. At 9 years, 12 times each year, 9 times 12 gives me an exponent of 108. So 0.038 divided by 12 is not going to be a real nice number. Long decimal, divide it and leave it in your calculator. Add the 1 to it. Do your exponent. And leave it all in your calculator to multiply by 9,150. So that we only round at the very end and get, oh my goodness. Too bad you guys here weren't here to correct me. I obviously need to make my exponent negative, which I forgot to do with my present value. The reason I caught that was because of something I told you guys earlier. Your answer for present value should always be less than what you started with. So I started with 9,150. I knew that 12,000 had to be wrong, so I went back and looked at my formula. So let's try that again with the right exponent. 12 plus 1 to the exponent 108 negative times 9150. That's better, $6,503.20 right now to get 9,100. So really the moral of the story is make sure you're using the right formula and don't mess up your formula. Joe invests $4,210 compounded monthly. How much will his investment be worth after 7 years? After 7 years is the amount in the future. So I want to use my accumulated amount formula. It's 1 plus 0.043 compounded monthly. So I'm going to divide by 12. 7 years, 12 times a year is an exponent of 84. So a little bit of practice at entering in your calculator. I enter it 0.043 and I divide by 12 and I get my answer, and then I add 1 and I get my answer, and then I do my exponent. 84 times 4210, which gives me an accumulated amount of $5,685.53 in 7 years. All right, you should be able to tackle those. Make sure you read them carefully and choose the correct formula and use the formula correctly.